all, welcome to another quick learning. Today I'm going to be going over t-tests in Excel. So you do a t-test when you want to compare two different populations that you've sampled from to see if they're in fact different. At least their mean is different. So here I've set up a condition 1 and a condition 2. I've created means and standard deviations up here, and then I am creating random numbers based on this mean and standard deviation. I do that using the norm inv, using the random number, and then I use the mean and standard deviation. And you can see it recalculates those because it's using the random number generator anytime I change something. So based on that, you can do a t-test to see if condition 1 is different than condition 2 in terms of the mean values. And what a t-test will give you is something called a p-value. The lower the p-value, the greater the chance that condition 2 is in fact different than condition 1. So to do a t-test, I'm going to delete this and start over. You go use the t-test formula. You select array 1, so this is your first condition, and then select array 2, and then you have to decide if you want it to be a 1 or 2-tailed test. If you just want to look at whether something is less than or greater than, then you would choose 1 tail. If you care about whether your condition is different on either side, then you would put in a 2-tail. So I'm going to say 1 tail because I want to see if this second condition is greater than the first one. And the type, so if you look in the documentation, so if I go here and I look up t-test, you will see your options there. So you have 3 different options. You put 1 if you want a paired t-test. You would use a paired t-test when you have things sampled from the same, let's say, patient or something like that. So let's say you have a test condition, you give them a diagnostic at the beginning of the test, and then you give them some sort of condition, and then you take the diagnostic test at the end of the test. So those two would be paired up, and you'd also need equal numbers of samples on both sides, in this case because they're paired up. If you're doing 2 sample equal variance, then you would choose 2. Or if you're doing 2 sample unequal variance, you could choose 3. If you don't know if they have equal variance, then you're probably better off choosing 3. So we're just going to choose 3, assuming we don't know they have equal variance, even though we set it up that way. And you can see we got a p-value of 0.89 for this simulation. So that means there's only a 89% chance that condition 2 is less than condition 1. And part of the reason why it's quite a high p-value in this case, even though we know that they're different on how we set them up, is because we haven't taken a lot of samples. So let's say we generate more samples. Let's go down to 20 samples. That will give us more statistical power, and you can see now our p-value is much smaller. It's 0.01, and we could simulate it several times, and you can see just by chance just how these line up. You're going to get p-values that kind of go around whether the conditions are the same or different anyways. But if you do a lot of samples, then it will start to merge into a small p-value. One of the ways that we can improve, if we make them a lot more different, you can see the p-value really goes down. But if let's go back to 6, if I increase the standard deviation, it will also make the p-value change as well. So if the spread of one of the conditions is much larger, it's harder to ascertain whether those 2 conditions have a different mean. So those are the things that you need to do when you're setting up a t-test and interpreting the p-value. So in most cases, people look at a 0.05 as a threshold where they will consider the 2 conditions different because there's enough evidence to support that. Otherwise, people usually say it's statistically insignificant. Like here, it would be called statistically insignificant because we haven't sampled enough to really show that there's a difference between these two in this sort of condition. If I change this back to 1, you'll see now we're able to tell much more easily because there's a higher peak from those normal distributions. All right, that's how you do a t-test. To look at condition 1 versus condition 2, you could use this for like A/B testing for a website or things like that. Just make sure when you're assigning your samples to either condition 1 or condition 2, you want to do it randomly so you're not introducing other variables that might affect the results. For instance, if you're doing an A/B test on a website, you don't want to collect all of condition 1 on a Monday and then switch it over to collect all of condition 2 on a Tuesday, because your population of users that use that website on Monday might be different from those on Tuesday. So you won't be able to tell if the change you made on the website is because of the day of the week you sampled it or because of the change you made. All right, I hope you guys are able to use the t-test in Excel. Thank you very much.